This problem involves implementing a recursive method. We're asked to write a method called print2s that takes an integer n as a parameter and that prints a single odd number multiplied by 2's that is equal to n. So we're showing n as a product of 2's and some odd number. So as an example here, the number 20 can be expressed as the odd number 5 multiplied by 2 2's. That gives you the 20. The number 80 is expressed as the odd number 5 multiplied by 4 2's. It does say that the 2's should surround the odd number with an equal number of 2's on either side, if possible. So here the 5 had 2 2's here and 2 2's here. This 5 had 1 2 here, 1 2 here. It says that if the expression has an odd number of 2's, the extra 2 should appear at the front. So in the case of 96, for example, there are 5 2's we want to multiply together, multiplied by the odd number 3. Since there are 5 of these 2's, 3 of them come at the front and 2 on the right-hand side. So there's an extra 2 to include, and it's included at the front. For a number like 2 itself, we want to express it as an odd number multiplied by some number of 2's, and so the odd number in this case is just 1, and there's only 1 2 to involve, so we have it there at the front. And we're told to throw an illegal argument exception if it's passed a value less than 1. I've included those various test cases in a program here that tests each of them. It prints out what it's doing, it calls the print2s method, and then completes the line of output. So our task is to write public static method that does the print2s. It's not returning any value here, so it's a void method. So we want to write print2s taking an integer value n. So our task is to fill in the various cases here for printing 2's. The easiest thing to do is to get that special case that involved throwing an exception. So it said throw an illegal argument exception if passed a value less than 1. So let's do that as the first thing. If n is less than 1, then we'll throw a new illegal argument exception. So that'll take care of that case. And otherwise, we have to think about other cases here. If we take a look here, this table has purposely shown you producing 80, the 2's for 80, in terms of the 2's for 20, and in terms of the 2's for 5. So take a look here. The 2's for 80, we end up getting 4 2's in total. 2 2's in the front and 2 2's on the right-hand side. But take a look what's inside of right here, the 2 times 5 times 2, 2 times 5 times 2. That's what you get by making a call on print2s of 20. And in fact, 20 is a multiple of 4 away from 80. So in other words, if you had the leading 2 and the final 2, if you kind of picked off the 2 at the beginning and the 2 at the end, what you're left with in the middle is print2s of 80 divided by those 2 2's. 80 divided by 4, which is 20. And similarly, when we do print2s of 20, there's a 2 here and there's a 2 here with this odd number 5 in the middle. So there's a pattern here that we can take advantage of. And the pattern involves, let's say if, I'm going to fill something in a second. But the pattern involves doing a system.out.print of 2 times. So there's a 2 times at the front of this. And then a recursive call on print2s, printing a different value of n. We can make that a question mark right now as well. And then system.out.print a times 2 on the other side. So we have kind of a leading 2 times and a trailing times 2 that in the middle has a different print2's output. Well, and if we're picking off 2 of the multiples of 2, then what we want to be printing in between is n divided by 4. So if we were asked to deal with 80, then we're taking care of 2 of the 2's, and what's left is to print the 2's that are left, 80 divided by 4, which is 20. Or if we had been working with 20, then we've taken care of a 2 and a 2. We want to print out the 2's for n divided by 4, or the 5 that's left. So when do we want to do this? This one I think is a little tricky in terms of figuring out the tests and the cases. But if you thought about it, when are you going to have a 2, a multiple of 2 that would be at the front, a multiple of 2 that would be at the back? What kinds of numbers are going to lead to an output that has at least those two 2's in it? And it turns out that the numbers that are going to have a 2 at the front and a 2 at the back are numbers that are divisible by 4. So it's not true of odd numbers. Odd numbers don't end up with any 2's at all. And it's not true of numbers that are only divisible by 2. They end up with a single multiple of 2, but not two multiples of 2. The only numbers that end up with two multiples of 2 are numbers that are divisible by 4. So the test that we want to have here is we want to say if n mod 4 is 0. If it's a multiple of 4, then we would want to have a 2 in the front and a 2 in the back. Now for now, what I'm going to do is I'm going to say, well, otherwise let's just assume it's a simple case. And so otherwise let's assume that all we're doing is printing out the number itself, because we don't have 2's to deal with. Turns out that's not going to be right. We're going to get some wrong answers. But this is actually a good start on getting the right answer. So let's go ahead and compile, make sure we didn't make any mistakes, and then let's go ahead and run this version of the program. And actually we get some interesting results. When we ask it to print the 2's for 80, we get 2 times 2 times 5 times 2 times 2. For 20, 2 times 5 times 2. For 5, we get 5. And if you look at our table, that matches the first 3 lines in our table. But we're getting the wrong answer for print 2's of 96 and print 2's of 2. Instead of getting 2 times 2 times, this 6 should be expressed as a 2 times 3. If you look in the table, we have a 2 times 3 here, where in our sample output we have a 6. And the number 2 is supposed to be expressed as 2 times an odd number, so that's not correct either. So we've missed a case here. We did a pretty good job with what we have so far. These are the cases where we have a 2 in front and a 2 in the back. But there are cases like these two here where there's an extra 2. So when we get down to a number like 6, for example, or a number like 2, those are numbers that are not divisible by 4, but they are divisible by 2. So that's probably the trickiest part of this problem, is recognizing that there's a special case for numbers that are divisible by 2, but not divisible by 4. So to fit this into our structure, we have to be kind of careful to think about it. If we made that our second test, we had n less than 1, and then we said if n mod 2 is 0, if it's divisible by 2, well, the numbers that are divisible by 4 are also divisible by 2. So we've got to be careful to put it later. So we'll have our test for numbers that are divisible by 4, and if we don't pass that test, we'll say if we have an n mod 2 of 0, if it's divisible by 2, then that's one of these numbers that's not divisible by 4, but it is divisible by 2. So it has a special output that's 2 times, and then the number that we want to output here is n divided by 2. And if we've done it right, we shouldn't have to worry about a recursive call here, because we know that when we get down to a number that's not divisible by 4 but is divisible by 2, it'll have exactly 1 2 times in front, and then what's left is the n divided by 2. Our else here then becomes numbers that aren't divisible by 4 and numbers that aren't divisible by 2. It turns out that those are all odd numbers, so we could kind of comment that if we wanted to. Odd numbers are just printed directly because they have no multiples of 2 in them. We can go ahead and compile and run this version of the program and make sure that we're still getting the right answer for our other problems, which we are. But now we're getting the answers that we wanted before. Instead of getting a 6 here, we have a 2 times 3, and we have 2 times 1 here. And that was what we were looking for. Our table shows us here. And so that ends up being our overall solution to this problem, is to have those 3 different cases other than the error case.